Hello, this video is going to take you through solving equations. Now, we have already done this with the calculator if you remember second trace intersect, but we're also going to talk about how to do it algebraically. Let's go back to what we've talked about before. When we have an equation and we want to solve it, we are going to put the left side in y1 and we are going to put the right side in y2. Now, I already have that up on my calculator. I have it in y1, I have it in y2. You should take a minute, pause the video, type this in on yours. And then we're going to go to Zoom and we're going to choose option 6. Zoom Standard is going to get you your normal 10 by 10 graph. From there, we have two solutions. How do I know that? We have 2 points of intersection. So if you recall how to do this, you're going to hit second trace. You're going to scroll down to choice 5, intersect. And what you're going to do is you're going to scroll over to where one of your solutions is. You're going to hit enter, enter, enter. That's enter 3 times. And it's going to tell you our solution is x equals 1. So what we're going to do is we are going to draw it out. I have that I already forgot what it looked like. There we go. We have something that looked like this. And a horizontal line. So my first solution was at x equals 1. Now you're going to go back to your calculator. You're going to do second trace, intersect all over again. You're going to scroll over to the other point of intersection that you want to find. And you're going to hit enter, enter, enter again. This time it's going to tell us our other solution is -5. So we already know that the answer should be -5 and 1. We write our solutions either by boxing them in as x equals -5 and x equals 1, or we put them in brackets. Typically, when we put them in brackets, we put them in numerical order. Now, we could also see these on a table. Remember, your solutions are when your y values are the same. So if we go to the table, I have my y values are the same at -5, and my y values are the same at x equals 1. And that makes sense because we wanted to have the answers of -5 and 1. Keep in mind that anytime you're equal to 0, you are going to have solutions that are, if they're real, the solutions are going to be your x-intercepts. Now let's talk about how to solve this algebraically. We have 2x squared plus 8x minus 10 equals 0. In order to solve an equation algebraically, you're going to factor it. And what do we see here? Hopefully we see that there's a GCF of 2. So you're going to write the 2 on the outside. Then we have x squared plus 4x minus 5 equals 0. We can still factor with the AM method. Your two numbers that multiply to -5 and add to 4 are, I believe, +5 and -1. Once you completely factor, you're going to create your t-chart. We have x equals -5, and we have x equals +1. We ignore the leading coefficient in front. Really, the reason for that is 2 does not equals 0. So it goes away, we ignore it. Anyway, you end up with the same two solutions, whether you do it by doing second trace intersect, the table, or algebraically. Let's try another one. So for the second one, I have y1, y2, pause the video, put it in your calculator like I have in mine. Gonna hit zoom 6 to see the graph. And this graph's actually not the best because if you look at it, it looks like you intersect once at the origin, but then what happens up at that top right? It looks like they would intersect again. So what I'm gonna do is I'm gonna hit zoom, and you could zoom out, or you could say, calculator, I wanna see higher. How do we do that? We go to our window, and if you wanna see higher, those are your Y values, specifically your Y maximum. So choose your Y max, how high you want to see. Maybe I wanna see up to 30. And then we're going to go and we're gonna graph it. And by doing that, and if you zoom out, it'll just not be as pretty of a view as doing it by hand. But if you do that, you can see now that we have 2 points of intersection, meaning you are going to have 2 solutions. So I have my parabola, which is y squared. Don't really know what happens in my background right now, but we're going to go with it. And then you have the other one, which is 5x. Now that graph is not really to scale, unfortunately, but you do have 2 points of intersection, so you should have 2 answers. Now I'm hoping that we can see that the first one is the origin, but you could do second trace, choice 5. We're already by the point of intersection, so you can hit enter 3 times, and you would see that x is equal to 0. You could hit second trace, choice 5 again. Now let's scroll up to that higher point of intersection that we're not sure about. Once you get close, hit enter 3 times, and it tells us that x is equal to 5. So I know that I should have 2 answers. I'm going to have 0, and I'm going to have 5. Let's double check in our table. In our table, as you go to 0, our y values are the same. Perfect. And then if you go to 5, your y values are still the same. So on the table, our y values match, meaning that it is the answer. Now, how to do this algebraically? When you have an equation, you do want to set it equal to 0. So I'm going to subtract 5x from both sides. And the reason I'm not bringing the x squared over is you want to keep the x squared positive. The term with your largest exponent, what we call our leading term, should be positive. And the reason for that is that it's easier to factor with a positive leading coefficient. Now, these two things have a GCF of x in common. If you take out the x, you're going to be left with x minus 5 equals 0. Notice how I'm not dropping the equals 0. This is an equation at all steps in our work. For the first one, we have x is equal to 0. The second one, we have x is equal to 5. So we got our answers algebraically. And let's try one more together. We're going to put it in our calculator, the left side in y1, the right side in y2. From there, what we are going to do is you are going to hit zoom 6 because we just messed up our window with our last problem. We want to reset it. And we could see that we have 2 solutions. So we have a parabola and a horizontal line. And we want to figure out what these 2 solutions are. So we're going to hit second trace, choice 5, find your solutions where your points of intersection are, hit enter 3 times. Ooh. Notice how my answer is not nice. This is x equals 1.87. So I'm going to put about, because I'm rounding, 1.87. And if we go back and find the other point of intersection, second trace 5, scroll to the other side, hit enter 3 times, and we're going to get negative 1.87. So this is one, using your calculator, with finding the intersection with second trace intersect is very helpful, because if your answers aren't nice numbers, integers, then you will not see them in the table. These values will never match, which is really unfortunate. So that's when we find the intersection on the calculator, when the table doesn't really work out. So it won't help when answers are not integers. Let's go about actually solving this one. How do we do it? We have 2x squared minus 7 equals 0. And the problem with this one is that there's no GCF. We can't factor it. So what do we do when we can't factor? Well, this problem is a little bit different than the others. If you notice, the other ones have 2 variables. 2 variables. When you have more than one term with a variable, like you have x squared and x to the first, you need to set it equal to 0, factor, and solve. But if you only have one term with a variable, not x squared and x to the first, we can actually call what we call isolate the variable. So we're going to bring 7 over, and we have 2x squared equals 7. We're trying to get x by itself. Since there's only one x, we can do that. We're going to divide by 2, and I get x squared equals 7/2, which, yes, is 3.5, but we like to leave the fraction. And then we're going to take the square root. Now, we do know that the radical and exponent cancel out. And on the right side, when you take the square root of a number, such as the square root of 9, well, 3 times 3 is 9, but negative 3 times negative 3 is also 9. So when you take the square root of something, it is actually plus or minus that value. So we don't have just the square root of 7 over 2, we have plus or minus the square root of 7 over 2. But that's not what we got in the calculator, right? So let's actually put it in the calculator and evaluate. We have the square root of alpha y equals 7 over 2. If you hit enter, you're going to get 1.8708, blah, blah, blah. That's the exact same thing that the calculator told you. So we actually did get the same answer, it's just that the calculator gives it to you in decimal form. You may not write it in decimal form. You have to write it, these are rounded. You have to write it as what we call exact. So we need to leave our answer as plus or minus square root of 7 over 2. But it is helpful to still check with the calculator, because we know, since the decimals match, that we have the right answer. Anyway, that is all for this video. I hope it helped.